So hi there, uh, this is our Splashkit demo video in which we'll go through some quick features of Splashkit and create an object-oriented game. We won't be creating a very complex game, but yeah, definitely our main focus here is to know about the functions of Splashkit, how to create a solution and how to execute them. So before beginning, let's just simply start by creating a new Splashkit file. So I'm just going to min-gw. Let me go to this location where I want to now make the file. So yeah, it is in E, exam3, to go to oops, then week 10. Yeah, and now I'm in this. Now let's just create our directory here. And the function for making the directory is mkdir, and just name of the directory, for example, it is a demo game. Okay, so I just press the enter and the demo game is created. Now let's just enter into the demo game, and here we have to create a solution. So the solution will not be directly created, but we'll create an Splashkit project skm.net new. So this command will basically generate a project inside the folder, the directory. So it is a Splashkit attached project. So when you open this, you'll get to know, like, you'll open the program, you'll see splashkit.stk is already there, which is beautiful. Now let's just save this and save it. The solution will itself get created. Yeah, just wait for it. Yeah, there we go. There is our solution. So we can use this solution to use Splashkit and just go about it. Just write codes, write games, do whatever you want. See, here you also have this option of going to splashkit.io, which is the documentation of Splashkit, and you'll get everything like how to install and all, what are the steps, how to install MySys, how to install Splashkit, Visual Studio Code, and how to go about it. And the documentation is the next big thing, the real game, the how to use. So these are the tools. You need to use these tools to create something amazing. So you'll be the artist now, and these are your tools. Like artists have brush, and we'll create a better, amazing art with these. Yeah. So we'll continue in some time. Yep. Okay, guys. So let's start with creating our first game using Splashkit. So this is the solution, Splashkit solution we made in the last video, and this is the program.cs, which is our main function. And in the main function, we are going to create a boilerplate of Splashkit. Boilerplate is just basic stuff over which we're gonna write the code. For example, in HTML, you have the boilerplate, header and all, and the body. You write everything similar here. We'll create a boilerplate. So the basic stuff is to create a window. So yeah, just like in any game, there will be a window popping up in which you'll play the game. So let's just create a window. Window is actually a function under Splashkit only, so that's why it's coming green. If I just code it out, window is nothing. C# doesn't know what a window is. So we are going to use Splashkit all in now. So let me just quickly write the code for window. uh, it is, see, it is even telling you the overloading thing, like what all functions or what all attributes you can have. It has a caption which will be written on the window. For example, we are creating a surviving the space game. We're creating a space game in which we're basically surviving. We are having a spaceship. So what is the width of the window? Basically asking. So let's just say 800 and the height would be 600. That would be really nice. So what this will do, this will simply create a window of 800 width and 600 height, and its name, the title would be surviving the space. So in the next method, in the next way, the next process is creating a loop. Now we'll create a do while loop. So we'll do something while this window is not getting closed. So here we'll simply write if not Splashkit will ask Splashkit window close requested. Which window? Only one window we're having. Surviving the space. Right? So here what is the direction we are going through is we have created a window and we have asked the program, or we have asked the Splashkit, like until the window is not closed or until the window is not requested to close, just do just be in the loop and just go on. So here comes the basic theory of how a game is written in Splashkit. So in Splashkit what actually happens is, first event is clear out the screen. So a window will be created, we have created a window, the screen will be cleared out, and then it will process the events, will process if the user has put any input or some event has happened, and after processing those events will print that on the screen. So the draw function will be there. After that, a refresh, the screen will get refreshed, and again the same will go on. So the screen will get cleared out, the events will be processed, screen will get refreshed. This is the loop will go on until the window is getting closed. So this is the whole purpose, or this is the whole idea behind this do while loop. So we want to be inside the loop. So a moving object or a game is continuous loops of pictures, of situational pictures are there. So this is what happens in the do while loop. So let's just complete our boilerplate. We are saying like this is the basic, complete basic of stuff. So let's just go ahead. Let's just create few things. Uh, yeah, complete this boilerplate. So we'll ask Splashkit, please clear the screen for me. Okay. After clearing the screen, Splashkit, would you do me a favor and process the events? After you process the events, Splashkit, would you just refresh the screen? And by doing all this, we are continuously asking Splashkit until the window is closed, clear the screen, process events and refresh. Clear screen, process events, refresh. So we're continuously printing out the current situation on the screen. So that is how Splashkit actually works. Now we have got these. First of all, these all rules are written. You'll find these in the documentation. For example, there is a clear window. You will find the C# syntax. There is splashkit.clear window. I can use clear window. I can give it a color. For example, if we try to run this program, so clear screen will give a white screen. So I should get a white screen. See, this is the caption. This is dimension, and 600 by 800. These were what we have given. Now we are having white screen on the board. We need to have something working here. That is so boring. So let's just keep working on it. So now let's get this code a little working. So what I want is, when I run this, I get a clear screen, white screen. So I want a spaceship over here. So let's just create a spaceship. So as we are here dealing with object oriented, we are not going to create a class inside it. Let's just create a separate class. So class will be named as spaceship. So let's just create a spaceship class. Yeah, we have created spaceship class. Let's just make it public so that it's available everywhere inside the namespace. Yeah, and don't forget to copy this Splashkit SDK using Splashkit SDK. Don't forget that. Now we have spaceship. Now spaceship will have its bitmap. So let's just make it private bitmap map. And spaceship also has its location, which is of point2D type. Now what is point2D type? Just go here and check point2D. Yeah, so that's how you're going to use this documentation. It is a lovely documentation, has so much functionality. So point2D represent a location in Cartesian XY coordinate. X value represent from the left edge of the bitmap. Basically it's saying if there is a bit, if this is a bitmap, X is going this side and Y is going this side, similar to how we create a window. So it is location is having XY coordinates. So our spaceship knows a bitmap and it knows its position. So now let's just create a constructor for spaceship. So the constructor will give a value to bitmap, which is new bitmap, and it has spaceship as its name, and its location will be spaceship.png. For the sake of easiness and for sake of saving time, I have created this resource folder in which I have image for this spaceship. So we are having spaceship right over here already present. Okay, so spaceship known as bitmap. Bitmaps get started, and spaceship also known as location. Location dot x value has to be somewhere around 300, let's say, and location dot y value, let's say 0, because I want my spaceship to start from the beginning. Let's see how it goes. So here it is, and spaceship must also be able to draw itself. Public void draw, and in the draw, what we are doing is we are basically saying bitmap to draw itself. So let's say bitmap dot draw. We are saying draw yourself to location dot x and location dot y. Okay, so we created a class. We created a class named spaceship who knows its bitmap and location, and it instantiate everything and knows how to draw itself. But we have not created any instance of this thing. So let's just create a quick instance. Like they come under the same namespace. They come under As they come under the same namespace, let's just quickly make spaceship named S, okay, which is new spaceship. So we have created a spaceship here, and in the process events, we'll just ask spaceship in the loop. We'll just ask spaceship to draw itself. So let's say draw. Let's say draw. So now we have created a spaceship in a main file, a main function, and we have asked him to draw. So it should be able to draw the spaceship, the bitmap. So let's just check it out. There is one more point. This resources folder is accessible by Splashkit only via terminal. Like you cannot here go and run through debugger. No, you have to go through the terminal. So let me have skm.net run. So let's see what we get. And here we are. So at least we are able to produce our spaceship on the window. Like it's there, but it cannot move anywhere. So still not a cool program, but we'll see how to improve. So we need a function to update its location now. So let's just quickly create an update function. In the update function, we are basically seeking that spaceship should be able to update its position. So and it depends upon the user interaction. For example, if now here comes the power of Splashkit. You can check what all things user has done. So if Splashkit dot key down, let's say key down, we are gonna use key code dot down. So we are saying when a down key is pressed, we are going to check if user has pressed the down key. Now I'll have to add to the y, which is plus equals 10. Means it's asking whenever the down key is pressed, just add 10 to the y value. Okay, so similarly like this, we're gonna have several if statements now. So if it is up key, we gotta reduce. If it is right key, then we gotta add to x. If it is left key, then we'll minus from x. So this is how it's gonna update its location. So the new values keep on changing again and again. But it is spaceship's capability. We are not actually using it. So let's just call this update function. So let's just try to run this program. Let's see how it goes. Yeah. Okay, there is some build error. Okay. Yeah. You gotta find errors too, because the more you code, the more chances of finding the errors. Okay, so oops. See, it is so fast. The thing why it's so fast is because refresh rate is very high. So we gotta restrict the refresh rate. For example, I'm putting 50 over here. So if I do something like this, it should be controllable, see? But even right now, the thing is not as per my command. Why? Because ideally, the spaceship shouldn't leave the left the screen. So I need to restrict it inside. So to restrict it inside, what I'm gonna do is, if the down key is pressed, I'm going to put some end conditions. Then the location of the bitmap, that is location dot y plus height of the bitmap dot height, the sum of these should be less than or equal to the window height, that is 600. Oh, not this. Yeah. Let's see if it works. skm.net run. So let's just try to run this. Okay, beautiful, beautiful. See, it's getting stopped. It's not going down. Yeah. So similarly, we need to adjust this for everything. We particularly need this for everything. For the sake of time, I'll just do it myself. Okay, so I've changed all the values, and let's see if our program is working. skm.net run. This is the command to run the program. Okay. Yeah, see, so it's under the screen now. Beautiful, beautiful. So far we're doing so good. So now what we need is, I want some objects here which are coming its way, and I want to be saved from that. That is the next aim of our program. Now to get this objects coming towards the spaceship, we need to create another class, which is probably a rock class. Let's say rocks are gonna come and hit. Let's just make it and hit the spaceship. Let's just make it public class. And what will a rock have? Rock will have its location, that is point. Oh, don't forget to add Splashkit whenever you make classes. Let's just add Splashkit quickly, and when private point 2D, so it has a location. Okay, so it says location, it has a bitmap. So rock has a bitmap. What else he has is velocity, which is a vector 2D. New concept given by Splashkit to you. Just great, just great. Just look at it. How much functionality Splashkit provides you. So vector 2D. So vector 2D represent direction and distance, similar to physics. Like it has magnitude as well as direction. So it will basically give you a certain direction, like where to move. So vector 2D has two things, x and y, and it basically tells direction and distance. Simple is that, simple maths. So we are using velocity because we want a rock to move on its own, not by user interaction. Yeah, so let's just create a constructor for the rock. So the rock will have location dot x. So location, x location, I want anywhere random. So Splashkit has this random function too, which is really great. So we have a random function, and we can put the values. So I want value within the screen. I can have values like anything, but I want to stay within our width, that is 600. Oh no, 800. 800 is the width. So I want somewhere between 20 to 750, let's say. So Splashkit is a random function including 20 and 750. It will pick up any one number and just give it a location. And y location, I just want Splashkit. I just want it to be equal to the, let's say, height. Equal to height. Height is 600, so Let's just put it high risk 600. Yeah, let's just put it 600 because I want a rock to begin from bottom to up, all the way up. So we've justified location. Let's just go on to the bitmap. Bitmap will create bitmap, new bitmap. Okay, so we'll give it rock name, and so name will be rock.png. Very nice. So let's come down to velocity. Now what is velocity? What velocity do I want? Now I can have splashkit dot random again. Again I can have something like from -7 to 7, I guess, because spaceship is moving 10. So let's just make it a little faster. Let's go from -15 to +15, so that few rocks are faster than spaceship. So if they are slower than spaceship, then it's of no use. The game will be boring. Want some interesting game. And the y velocity should be decreasing, and I can say it should be somewhere around from, say, -15 to -2, I guess. Yeah, so these can be the values in the constructor. Now what should rock be able to do? Rock should be able to draw itself. Void draw. So in the draw function, it should be able to just simply draw its bitmap. Draw and location at. So we have to give the coordinates in double where you want to draw the bitmap. Yeah, and the next will be update. It should be able to update itself too, no? So in the update, the location will get changed. So the X location will become, just velocity will get added. Simple. Not hard and fast rule. No hard and fast rule. X Y location will be, the Y velocity will be added. Okay. What else should rock be able to do? Rock should be able to tell if it has collided with the other object. So it should be able to return a bool to check collision. So in check collision, it can take spaceship, no? It can take spaceship in check collision. It can take a spaceship, and there is one more function we're going to discuss. Another function provided by Splashkit, that is, we can have function named Splashkit dot bitmap collision. It is bitmap collision. So it takes, the best part about C# is Visual Studio is you get all the overloading methods, like what all attributes do they, what are things do they need. So it can have its own bitmap, it can have bitmap's location, and it knows now here's the catch. This function basically does not know if it can change spaceship's value or not. So here is a huge catch. Like here you want to change the value, you want to get the value, you want to get the S value and Y value of spaceship. So they need to have a setup, if you can get what I'm saying. So there should be a method in spaceship that returns the location. I can have for this purpose I can just have a property named public point to the location, and this property will simply get me a location. So when location will be called, it will just simply send the location. So here, instead of x, what we can do, s can have location and location can have an x. So we are going to spaceship, we are saying spaceship, okay, I want to go through your location property, and location gives the location, and from that location I need your x and y values. So here's some error here, that is bitmap. It should be able to return its bitmap too, because we need the bitmap to check the collision. So we have one more property here, that is returning the bitmap. I can have a property named bitmap which will simply return the bitmap of spaceship. It has to be into the get because it is a getter method. So here what I can do is I can put a bitmap as dot bitmap, yeah, and now it's fine. Now what this function does is it will take the first bitmap, it will take the second bitmap, it will know the location of the first bitmap, it will check if the second bitmap is on the same location. So if two bitmaps are the same location, they have collided. It will say, okay, yes, you have collided. So the rock is able to draw itself, update itself, and tell if the collision has happened or not. That's pretty much it about the rock. But our problem is still not solved because we don't want a single rock. We want multiple rocks to come towards the spaceship and the spaceship to tackle all. So the next part we are going to focus on how we'll have these multiple rocks communicating with each other and coordinating throughout the game. Now as I have created rock, like we cannot go ahead and create a rock instance in this main program because we just don't want one rock. We want many rocks all of a sudden coming and hitting spaceship. So uh, we're gonna have a list of rocks, but creating too many instances over here, that is in a main program, it's not a good idea because it is going overloaded. That's too much chaos for one class. See, program class is like a chairman or the owner. The owner has to do everything with profit and losses and see the business stuff and expansion of the business. He cannot just waste time on managing things. So when too many workers or too many liabilities happen, there has to be a CEO. So now we are going towards the object-oriented approach. That is a manager. There has to be some manager who will handle the coordination between the objects, and that manager will be instantiated in the program, and program will be responsible only with the communication through that manager. So we are gonna appoint just like a CEO, and the owner can directly have conversation with CEO and know everything or deal with everything. Similarly, we're going to have a game manager which will deal with spaceship and rock, particularly rocks and spaceship, and program just gonna deal with that manager, and that manager is gonna deal with almost everyone and try to coordinate. So let's just go ahead and create that manager. And yeah, let's just create a class. That class will be named as Space Game Manager. So we'll have Space Game Manager. And what will this space? Don't forget to add this Splashkit thing in the beginning. So this Space Game Manager needs to know what all things. First of all, it needs to know about the spaceship. So it knows about the spaceship. It needs to know about the list of rocks. Rocks. It needs to know about the list of rocks. Okay, these two things it needs to know. And now let's just go over to the constructor, that is public space game manager, and let's just bring them to reality. Spaceship is equal to new spaceship. Okay, and rocks is equal to new list of rocks. Okay, so now what it should be able to do? First of all, it should be able to draw itself. So in that, it should be able to draw two things. That is, spaceship, should be able to draw spaceship, and for each rock, for each rock R in rocks, it should be able to draw the R dot draw. It should be able to draw that rock, right? Beautiful. Else, what else can it should be able to do? It should be able to update. Now in update, what all things it can update? It can update the spaceship, and for each, similarly like this, it has to update everything. I'm being lazy and I'm copying the entire code, because being a programmer and you're lazy means you're a good programmer. Yeah, so it updates, but we are losing a point here. Like, what is inside it? Who is going to add? It's going to add. So we need a function which will add the rock. So this function will take a rock R, and then it will simply add it to the rocks. Okay, now who will decide when the rock will get added? For that we need a timer. We need a new class, that is timer. Why we need timer? Because if we don't have timer, then the rock's gonna pop up because it is very fast. The things are going really fast, and the entire window will be blown up with the rocks only. So we need a timer, we need some controller. So it should have a timer, and the timer should be, it's a Splashkit function. We can start a timer. So we have started a timer, and let's just check this timer class once. Hey Splashkit, tell me more about timer. So here we are, timer. It returns a new timer. Ticks 0, so timer can tick. So what's timer ticks? Splashkit literally tells you almost everything. That's the number of ticks, milliseconds. So it tells you about the milliseconds. How many milliseconds have gone. So we are going to now instantiate rock. So how will you instantiate a rock is, first you'll check timer dot ticks. I'll say if timer dot ticks divided by 1000 is equal to, oh no, divided by 1000, let's say I want every third second. First the modulus 3 equals 1, I'll say every third second. Modulus 1, if, so it is an if statement. If this is true, I'll just create a rock. R is equal to new rock, and then I'll just add this rock to the list. It will call it and it will simply add it. Okay, so there is an error here. It needs a string. This timer needs a string. This timer needs a string, which is its name. Its name is timer. So no errors so far. Okay, so we have created a manager who has the list of rocks, who has spaceship, who can add rocks, and who can draw and update. But we are not calling this instantiate rock. So in the update, we also have to call instantiate rock. We'll say, okay, you have to now instantiate the rock. So let's just go to the program now. Now this spaceship thing we don't want. This spaceship has nothing to do. Everything will be done by space game manager my game equal to new space game manager, and we'll just update my game draw and my game update. Okay, so let's just run it, try to check if we're doing right. Okay, so oh my god, there are too many rocks. Okay, so but our code is working, it's just that there are too many rocks, so we just need to deal with the quantity now. Okay, so I have added just a random number, and if that number between 0 to 100, if that number is less than 20, we got this, which is fabulous. So let's just check if it works. skm.next1, let's see if it works. Okay, yeah, that's a little better. It's still very hard, but still better than before. So we are kind of having our game working right now. Now in that code, we observe one thing, that though rocks and spaceships were present, but they were not able to capture each other. They are just bypassing themselves. So right now our main responsibility is to make them capture. And how to make them capture is, we'll check if they collide, and if they collide, we'll just remove the rock from them. So we need to have a remove function. Now what the remove function will do, the remove function will check that for each, let me see, for each rock R in rocks, so we'll check for each rock R in rocks if we'll check if R dot check collision needs to have spaceship, and we having a spaceship that is spaceship. If it is true, then we just need to add this rock to be removed list. For that we need to create a to remove list. Let's just create a new list of rocks named to remove. We'll name rocks to remove equal to new list rocks. Okay, so we'll just add this, or if they collide it will return true. We'll just add rock to this. Okay, and when this for each will end, we'll just remove all this rocks to remove from the rocks. So in the next go, what we'll do is for each rock R in rocks to remove, we'll say rocks remove R. So first we are checking like if spaceship has collided with something, and then we are adding it to the remove list. Okay, now we are iterating through the remove list and removing all those things from the rocks. So that's what we are doing. So that is pretty much it. It should be able to remove all this. So it should be called, remove should be called in the update only. So instantiate object remove, it should come under this.